In set theory, one of the most fundamental operations we use is the union of sets. The word union means to bring together or combine. So when we perform the union of two sets, we are collecting all elements from both sets without repeating anything. This operation helps us form a larger set that includes everything present in either of the original sets. The union of sets A and B is written as a union B, and the symbol used is a cup shape like a wide U. Mathematically, it is written as a union B. It includes all elements that are in A or in B or in both. For example, if A equals brace 2, 4, 6, 8, close brace and B equals brace 6, 8, 10, 12, close brace, then a union B equals brace 2, 4, 6, 8, 10, 12, close brace. Remember, elements common to both sets, like 6 and 8, are written only once. Let's imagine this visually using a Venn diagram. Draw a large rectangle to represent the universal set. Now place two overlapping circles inside it, one for A and one for B. The entire shaded region covering both circles represents a union B. This helps us see that we are including every element from both sets, whether it appears in one or both. Now let's go over some important properties of union. Commutative law, a union B is equal to B union A. Associative law. A union B grouped first, then union with C equals I union. Grouped with B union C, identity law. A union, the empty set, equals a idempotent law. A union A equals a universal set law. A union, the universal set, equals the universal set. These properties ensure that union operations remain consistent and logical. Here's a practical example. Let A be the set of students who play cricket and B be the set of students who play football. Then A union B is the set of all students who play either cricket, football, or both. This way, we avoid duplication and ensure that every participant is included. In real-world data handling, union operations help us in survey analysis, database merging, and logic-based filtering. To sum up, the union of two sets gives us a new set that contains all elements from both original sets. The symbol for union is pronounced as a wide U and written as a union B. We do not repeat elements and we include everything present in either or both sets. This operation is essential in understanding how sets combine and helps build the foundation for further concepts like intersection, difference, and complement. Next up, we'll explore the intersection of sets, where we focus on common elements only.